Linear Optimization by Justin D'Souza. The learning objectives of this lesson are to use linear programming to solve applications and to recognize situations in which there are no solutions or more than one solutions of a linear programming application. The keywords in this lesson are optimization, linear programming, objective function, constraints, feasible solutions, multiple optimal solutions, and unbounded. So we'll come across all these keywords as we go into the lesson. And the first concept is about linear programming. Now here you can see a set of equations, right? Now, linear programming means you will have a set of lots of equations, or they are also called as constraints in terms of inequalities. Now, to understand what is a constraint, now imagine you're cooking and you want to make a dish. So you need minimum of 2 onions for that dish and 1 tomato. So the constraint over here is you need minimum 2 onions. So it will be, if onions are x can be greater than or equal to 2, but it cannot be less than 2. And you need at least 1 tomato. So y, if it's tomatoes, it should be y greater than or equal to 1. So these are the constraints. And then we will have set of constraints, and when we graph it, we will get a feasible solution region, in the sense whichever the inequality falls under. See, now for example, this is y equals 3. But here we knew y is less than or equal to 3. So anything below this is the solution region. And for this equation, we had greater than. So anything above this is the solution. Whereas x is greater than 0, so positive domain only. So right side over here. So this would be the solution region. And now this solution region is many points, right? How would you know the exact or important points? That would be from the objective functions and the vertices. So if you look at the vertices over here, these endpoints where two or more equations meet up, see, now this is a vertex over here, 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 all these vertex points, right? Here you will either have the maximum or minimum values. So how do you find out is these vertex points, whatever it is, x and y value, you plug it in the objective function and then you get the maximum or minimum values, and that's how we can do optimization. Now we will look into a problem you'll understand much better. Now before that, feasible solutions are anything that's under this, but we find the vertices and plug it in the objective function and then get the most desirable optimum result. Our first example is to find the maximum and minimum values for this objective function. So objective function will be given in the question. These are the constraints over here given. We need to solve them up and find the vertices and plug it back over here. There are many methods to solve this, but the direct and the easy method would be just graphing them up, finding the vertices, and then plugging it back into the objective function and solving it. It's just a 3-step procedure. Now, graphing depends. Some do graph by making tables. It takes a long time. Now, what I would suggest is directly start using the slope-intercept form. Y is equal to mx plus b. Generally, your questions, the constraints will be in the standard form, that is ax plus bx plus equals c. Sorry. This is very important to find the vertices. So this form is required and this form is required. Now, how do we do this is, let's take the first equation, x plus y less than or equal to 8. Now, to get into the slope intercept, I need to write y alone. Let me leave it over there. And here I won't change the inequality. I'll write it as it is and take this x to the other side. It's minus x plus 8. So this is the answer. Now, what about the next one? Similarly, we have 2x minus y. Now, this is important. Minus y less than or equal to 5. Here now, let's not move this y to the other side. Yes, it'll become positive, but it will move to the right side and it'll be a bit confusing. So what I'll do is, I'll leave this here and move this to the other side. So it'll be minus y less than or equal to minus 2x plus 5. Now, there is a rule when we have inequalities. In order to change the signs, you need to flip the inequality. In the sense, I can't change the sign throughout this equation, both the sides. This will multiply both the sides by negative sign. This will be positive y. This will be positive 2x. This will be negative 5. All the signs have been changed. That's fine. But what happens with the inequalities? Since we are dealing with inequality, this flips. Now, this is your another constraint. Y is greater than or equal to 2x minus 5. And then this one, x is greater than or equal to 0. What does it mean? X is greater than or equal to 0 is all the positive x domain, and for y greater than or equal to 0 would be upside, all positive values. So it's only the first quadrant we will be dealing with, only the positive values. That's fine. These two are very simple. Now, what about the first equation? This is the y-intercept. So this is 6, 7, somewhere over here. This y-intercept would be, and it's a minus, and we know the slope is 45-degree line. If you have a scale, you can draw a 45-degree line. This is not accurate, but just for an understanding. Now, what about this one? I have minus 5. That would be somewhere over here, right? Minus 5. And it's 2x, so it's a bit upwards, okay? This is not accurate. It should have gone a little more upwards, but just for, it'll be somewhere over here, I think, so the touching point. But anyways, just for the understanding. And then over here, we have x is equal to 0. That means, see, this is the line. X is 0 is this line over here. And this is one more line, y is 0. So these are all the lines. Okay, 4 lines we obtained. Now, if we extend this, there will be 4 vertices, somewhere over here, somewhere over here, somewhere over here, and somewhere over here. One is 0, 0. That is very straightforward because we have 2 0 lines. Now, which is the solution region? Is this the solution? This, which one? Now, let's look into the inequalities. The first line which we drawn, it was y is less than or equal to. Because it's less than or equal to, every way it's straight line. If it was just less than, then it would be dotted lines like this. But since over here we have less than or equal to, we have all solid lines or straight lines. And since it's less than, it will be pointing downwards, everything. Okay, it's very simple. If it's less than, it's downwards. And next one was greater than, it's all everything upwards. So that's the solution part. This, it's going inside. And then we know over here it was x is greater than 0. That means it's positive over here. And y is greater than 0. It's again positive. So this over here, which I'm shading now, is the solution region. And the 4 vertices, those are the important points, because when we substitute those in this objective function, we are going to get maximum or minimum. Now, how we know these vertices? See, some of them can be easily found out. Now, this is 0. We know this is 0. And what is this? This was touching at 8. So this point could be 0, 8. And what about this? This is vertices 0, 0. What about this? Now, we can't be so accurate because I did not accurately draw it. It might be 2 or 3. It might be anywhere. But now I'll tell you how you can accurately find the equations, the vertex points from the equations. First, you need to mark the equation. So let me mark them up. Here, I will write the standard form, the initial standard form, not the slope-intercept form. Here, the standard form was 2x minus y less than or equal to 5. We can write it as equal to 5 itself. It's fine. Okay, it's an equation. This is the line. Greater than or less than, that just means which part will be the solution region. That's it. Now, what about this equation over here? This was x plus y equals 8. And what about this one over here? This one was x is, this is y is greater than or equal to 0. So it will be y equals 0. So y equals 0. And lastly, we had x equals 0. So these are the 4 equations, right? Now, let's just take the calculator and find the vertex points. How you can find the vertex points is, in the calculator, you need to press more, then go to equation, and first option gives you simultaneous equations. 2 equations can be typed in. So let's see, the first one is, which is this equation? This was x is equal to 0, and this is x plus y equals 8. So I'll type this out first. 1, 1, 8. And then we have over here 1. That is, a is all the coefficients of x, b is coefficients of y, equal to c. See, this is the standard form, right? A, b, and c is whatever is at the equal to over here. Now over here there is only one x, nothing means one x, plus there is no y means it's 0y, so it's 0, and lastly we have 0 equal to 0. So what is the point meeting over here? 0 and 8. That's the answer. We already knew that, but we don't know what's this. So let's find this. Now, which are the two equations? That is this and this equation. X plus y equals 8, and over here it can't be seen now. It's 2x minus y equals 5. So let me just solve it up over here itself. Let me go to mode 5 1. Now once you are in the mode, you can just press on, you'll be back to the same mode. It'll be 1 1 8, and we have 2 minus 1 and 5. So the solution points over there is 4.33 and 3.67. So I will write it in terms of fractions itself because you will have the accurate answer. So x is 13 by 3, and then the y value, just press equal to, you will get the y value. It was 11. It is 11 divided by 3. So these are the two vertices we just now found out. And what about the other two vertices? So again, you can just press on. Already one of the equation will be saved. Now for this line is what? 2x minus 5. So I won't change the below line. Why? Because it's the same one. I'll just put the first equation as, what is this? Y equals 0. So it's 0, 1, 0. The second one is already typed in. So equals, it's 2.5. See, mine was not accurate, right? It should have been 2.5. It should have been touching over there, and 0. X is 2.5, y is 0. So let me just note it out over here. 2.5 comma 0, and last one was 0 and 0. But even if you want to try it out, yes, you can definitely try it out. If you press on over here, the first one equation, y is y equals 0, it's already typed. Another one is x is equal to 0 1 0 0, and the answer is 0 0. You don't need to do that, it's obvious, when it's touching over here to the vertex, but the other things you had to do it. So now we found out the the vertex, x and y values of vertex. All you need to do is substitute all these vertex points in this equation. So I'll just do it out over here. Now this objective function is very important because when we substitute all the vertex points in it, we will get the maximum and the minimum values. So let's do it out over here. So instead of f of x comma y, let me take the first vertex point 0 comma 8. That would mean x will be 0. Instead of x plus 3y, we will have 0 plus 3 into 8. That's the answer. So we need to solve for all the different vertex points, 13 by 3 comma 11 by 3, f of 2.5 comma 0, and lastly function of 0 comma 0. And if you substitute it, only for this I will write it out. In the next problems I'll just put in the calculator. You can also do it, but if it's in writing, please make sure you write these steps. Okay, what I'm writing now. So here x as it is 13 by 3 plus 3 times y 11 by 3. That will be equal to some value over here. Again 2.5 plus 3 times 0 would be 0. So I'll not write 3 times 0. It's basically 0. And over here we have 0 plus 0. It's 0. Over here it's 2.5. And over here we have 8 times 3. That will be 24. And now this we can just put in the calculator and solve. Now one more thing, in your exams, to save time, if you have many points, what you can do is, now over here we will just substitute 13 divided by 3 plus 11 by 3 into 3 will be 11 itself. So the answer would be 15.3 over here. So now, which is the maximum value? 15.3 is somewhere in the middle, right? It is not the maximum. The maximum will be obtained at 0,8 and the minimum is at 0,0. So these two are the solution regions. When x is 0, y is 8, and there you will get the maximum value. Whereas when x is 0 and y is 0, you will get the minimum value of 0. So by comparing all the four vertex points, we can easily get the maximum and the minimum. So this is how we basically solve it up. You can, the step one would be just converting these to slope intercept form, then graphing, and then putting it in the vertex, and then solving it up. Now here you don't need to make an accurate graph, just randomly sketch it by just basic understanding of the slope intercept form, and then you can rearrange, you can change it up, because when you solve for the vertex, when you put this in the calculator and solve the vertices by solving the two equation, you will understand the accurate points. So then you can really rearrange the graph if you want. You can just write the vertex points and then put it in the objective function and solve it up, and there you go, that will be the answer. So this is the graph. We had got a similar one. We didn't get exactly the correct one, but yeah, somewhat similar. I'd known that it's not very accurate, it should have been little up, and yeah, it's very close enough. You can see it's very, very close enough. And the vertex points, these are the vertex points which we also got. We had got 0 0, and then we had got 13 by 3 and 11 by 3. 2.5 is 5 by 2 comma 0, and lastly is 0 comma 8. So these were all the four vertex points, 1 2 3 and up over here 1. And the finally we got the maximum value of 24 at x is 0 and y is 8, and the minimum was at x is 0 and y is 0. The f of x was 0 as well. So this is how we basically solve these problems. Please do practice more problems by yourselves. I will quickly try to solve one over here. I'll do 1b over here. We will try to do it as quickly as possible. The first thing what I can see is there is already the slope intercept form. That's well and good. So these are the three constraints. I will quickly try to graph them up. We have -2, so over here, and then greater than or equal. The slope is positive 2x, so it'll be something like this. Then what else? We have -12, that will be somewhere very down, and it's negative slope, so it should go down something like this. Okay, and it'll be up like this downwards. So I'll extend this as well. And what about this? Y must be less than or equal to 6. So this is 6 over here. If I draw a straight line, it's all solutions less than that. Okay, so now if we look through them, all the solutions less than this, okay, is the solution region. What about this one? Greater than that. Greater would be all above it, right? Above it. So this is one, and even over here greater than, so it will be all above it. So if you have any line like this, just see above, below, like this, above, below. Above is positive, greater than, sorry, above is greater than or equal to, below would be less than or equal to. Since all are greater than or less than or equal to, see this symbol is there, equal to symbol is there, I have to draw solid lines, otherwise it would have been dotted lines. Now here, this is the solution region, but you need the vertex points, that is important. Okay, this is a rough solution figure. What about the vertices? So you need the calculator, but before that, please mention the equations. This is y is equal to 0. Now, when I'm mentioning this, please don't write in slope intercept form. Write it in the standard form. I need ax. So bring this to the other side. Now, this is -2 b intercept. So this is the equation. It will be -2x plus y equals -2. And what about this equation? It will be 3x minus y equals -12. So these are the three equations. I just realized that this is y equals to 6, not 0. Now we will solve the vertex in calculator. All we need to do is mod phi 1. Let's put in this equation is 0, 1 and equals to 6. And the next equation is -2, 1 and -2. And the answers are 4 and 6. So you can see this graph of ours is not so accurate because I didn't accurately do it, but you can understand it's 6 comma 4. Sorry, it's 4 comma 6. My bad. The x value is 4, Y value is 6. And that's reasonable, it's close to 4 and 6, yes, because this is flat line at 6. Now to find the next vertex point, all you need to do is type in the two other equations. Um, Over here, as I can see, this is again plus, sorry for that, I've done some mistakes. 3x to the other side, over here it'll be positive 3x plus y equals negative 12. You need to type this equation and this equation over here. Now since we have already typed in the two equations, press on and you'll go back to the equations. Minus 2x plus y equals minus 2 is already typed in. So I will just type 3, 1 and minus 12. So the answers over here are minus 2 and minus 6. You can see they're not so accurate. Minus 2, minus 6. A graph is not exactly accurate, but it's very close enough. So that's enough. That's more than enough. You don't need accurate graphs because all you need is the vertex points. So this is what I'm looking for, and I got that. And the last vertex point over here is where y equals 6 and 3x plus y equals minus 12. So let's type it in. Let me just change this equation to 0, 1 and 6, and here you go, the final answer, minus 6 and plus 6. So these are the vertex points, minus 6 plus 6. Three vertex points we have obtained. Now all you need to do over here is substitute these vertex points in the given objective function. This is the objective function, f of x comma y, right? So all I do is f of, instead of x comma y, let me start with minus 6 plus 6. F of 4 comma 6, and lastly f of minus 2 minus 6. You can do the substitution. In exam, if it's writing, please do the substitution. 5 of minus 6 minus 6 of positive 6, and then put the answer. But now I'll directly solve them in the calculator. Here, let's go out of the mode. We can go out of the equation mode by mode 1, or you can just clear the calculator by shift 9, 3 equals an AC. Now here, this is the given equation, phi, and what you need to do is substitute the x value, that's minus 6, plus, sorry, it's minus 6 times y is 6. So the first one is negative 66. Just write it over here. And now then we will do the next one. Phi is the same thing, only the x value changes to 4 and it's the 6 value itself. So the answer is negative 16. Now you can see this is a minimum value, negative 66. It's a small number compared to negative 16. And lastly, we have minus 2 here and minus 6 here, and it's positive 26. So the maximum value is this. So maximum value is at minus 2 and y is at minus 6. The value we obtain is 26. And the minimum value of minus 66 is obtained when x is negative 6 and y is positive 6. So that's how we solve it out to here. So this is the answers. Make sure you solve these problems by yourselves. It doesn't matter if your graphs are very accurate or not, that doesn't matter, but your vertex points needs to be accurate. So please focus on the vertex point, solving the equations, and then substituting back into the objective function. Here now we have real world problem. A garden center grows only junipers and azaleas in a greenhouse that holds up to 3,000 shrubs. Due to labor costs, the number of azaleas grown must be less than or equal to 1,200 plus 3 times the number of junipers. The market demands for azaleas is at least twice that of junipers. The center makes a profit of 2 dirhams per juniper and 1.5 dirham per azaleas. Write the objective function and list the constraints that model the given situation. Now here, the first part is just to write the constraints and write the objective function. Objective function is either profit or loss or, getting the final output. Now here they have clearly mentioned how much does it cost, 2 dirhams and 1.5 dirhams. This is the objective function. Now the first one, junipers, I take it as x and azaleas as y. So the objective function f of x comma y will be equal to what? It will be equal to, how much is junipers? 2x plus 1.5. y. That's it. Now, what are the constraints? This is objective function. The constraints that model the situation is, let's read the question again. The first one is over here. X and Y that holds up to 3000 shrubs. So X plus Y must be, maximum is 3000. Holds up to, that means it can't go more than 3000. It must be less than or equal to 3000. And what about the other things? Due to labor cost, the number of azaleas grown must be less than or equal to, now azaleas is Y, less than or equal to 1200 plus 3 times junipers, that's X. This is the second equation. And lastly, we have the market demand for azaleas is at least twice. So now Y must be at least, can be greater than, okay, must be less than, at least must be greater than or equal to twice that of junipers. So these are the three constraints, and then we know how to graph it out. See, now here 2x plus 1.5y, and these are the constraints one by one. Y is greater than or equal to 2x. Y is, now here I have written it accordingly, but when you're writing it, in the slope intercept form or standard form, we write it 3x plus 1200. It's the same thing, so it's 1200. This and this are the same equation. I've just rearranged the right side. That's it. And lastly, what do we have? We have, when we add these both, it must be less than or equal to 3000. And over here, x and y cannot be negative, so it must be greater than or equal to 0. That is obvious because it's a real world problem. So that's it. And then the sketching of graph, we have done similar things before. Over here, when you graph it, we all these, you get graph something like this. But make sure you're just doing in the first quadrant. Why? Because these are plants. You can't have negative plants, right? You can't have negative numbers, so it must be in the positive quadrant itself. And then find the vertex points. Solve these two equations just like what we have done before, and then find the vertex points, substitute it in the objective function which we had written just a while ago, the objective function over here, and then you will get the maximum limits. So over here we have to what? Maximize the profit, right? Just see which gives you the maximum profit, which vertex, and that many number of junipers and azaleas must be grown. So over here we find, so this is the objective function and we're substituting all, and we can see maximum value of 5000, a profit of 5000 can be obtained if 1000 junipers are grown and 2000 azaleas are grown. So that will be the maximum profit. So this is what needs to be grown, not anything else. Here there is another real world problem. Please do try to do it by yourselves. It's just like what we had done just a while ago. At least do write the objective function from this and the constraints. So the graphing for each and every problem in this will be the same. You have to just look into what they ask you. Maximize means after you find the vertex points and put in the objective function, you'd get values, isn't it? The maximum value. If they ask minimum profit or minimum loss, say for example, then it would be minimum value. Now here, let's look into the question. A lumber mill can produce 600 units of product each week. So I'll just write it out. 600 products each week. Okay. Now they have not told exactly which products, but I just, because I know there are two different type of products, X plus Y will be, can produce up to, must be less than or equal to 600. Maximum capacity is 600. To meet the needs of the regular customers, the mill must produce at least 150 units of lumber. So this X will be lumber, okay? So X is lumber. And the Y, what is Y? It's plywood. Y is plywood. That's the other one. Now, X must be at least, that means it can be less than or equal to 150, and at least, sorry, it must be greater than, at least is always greater than, okay? X must be greater than or equal to 150. At most or up to would be less than here. Y is greater than or equal to 225 units. And what is the objective function that's given over here? Here also, you must know that X must be greater than or equal to 0. Y must be greater than or equal to 0. Why? Because this is quantity is a object which can't be negative. Okay. Whereas the objective function x and y is equal to 30 is for number 30x plus 45y. This is the objective function and these are the constraints. And there you go. If you just solve this up, you will get the answer. So you can see it's 30x plus 45y, x is great. Now, this is not always mentioned, but this is understood. X is greater than or equal to 0, y is greater than or equal to 0. It's understood. It can't be negative, that's it. And over here, these are the other constraints. So remember, it's greater than equal to, and over here, the first one was less than and equal to. So this would be the answer. If you graph it up, you will get these equations. The vertices, just put it in the objective function, and you get the maximum profit when x is 150 and y is 450 units. So this is the point. We now move on to the no or multiple optimal solutions. This is another easy one, just like the previous topic, same concept, but just a little bit of change. But before that, I just want to quickly request you all to subscribe to my channel if you're finding my videos helpful. The reason why I always ask to subscribe is only 10.4% of the people who watch my videos subscribe, whereas more than 89% are not subscribed. If you're already subscribed, thank you so much. And I would greatly appreciate if you could like and share my videos with your friends. Now then, the topic of no or multiple optimal solutions. Here you can see this particular graph. This is bounded, it's all fine. What's the matter over here is each point on this line will give you a solution. So you have multiple optimal solutions. That means this entire line basically is a solution line. And in case of unbounded regions, here it's very hard to pinpoint what is happening, right? So basically you have no maximum value over here. Now, in such cases, you will definitely get a minimum point. I mean, you need to check, okay? You will have only minimum, but generally you won't have a maximum value because it's unbounded. The problem will be such that in such cases, they'll ask you the minimum or the ones which you obtain from the vertex points will be the solution. We'll look into the problems over here. Same concept, same like just the previous one. You need to first see all the constraints and the objective function. The objective function is given here. All these are the constraints. Once you graph it up, you will get the vertices, right? You can easily, equate these two equations and then find the vertices. I'll just equate them and find the vertices here in the calculator. You have to go to mode phi and 1. Now let's start from the first line over here. This line is y equals 6. So it's 0, 1, and 6. I'll take this red line. That is, it's not 1, sorry. The first is x value. So it's 2, 1, and then we have 18. So the point is 6 and 6 over here. Now, for this particular graph, it's so easily graphed, so perfectly graphed. You can easily get the vertices by counting it. But the reason why I'm not doing that is because when we graph, it won't be so accurate. Okay, so you just can't count them. So it's over here 6, 6. And what about this point over here? Same thing, you need to graph. But since I've used this line, I'll use the other two. 1 second. Press on. This is already typed in. So which is it touching to? X is equal to 8. So let me write 1, 0, and 8. And it is at 8 and 2. So this is the next point over here, 8, 2. Now here this is 0, 0. We do not need to mention that because it's obvious. Over here, we have to just find the maximum value. And if you substitute 0 and 0, it won't be maximum because you have other positive values. You will get a minimum point. So, if you just look at it, you can even analyze that and just ignore that point as well. Now this one, you don't need to put in the calculator because I know y is at 6, so it should be 0, 6. And even over here, since x is at 8, it will be 8, 0. Those are simple vertex points. What about these two? Here also you can use the calculator, but without calculator it's very simple. X is 8 and y is 6. So that's it. So all the vertex points are obtained. Now what you need to do is substitute all of these in the objective function. So one more thing, let me make this clear. If you have straight lines, it's very easy to directly write the vertex points. Only when it's slanting, use the calculator. Otherwise, just directly write them out. Now here, if we put all these points in the objective function, let's look over here. See this? It was, now it's changed, but still 0, 0, 8, comma 2. Yes, we obtained that. 0, comma 6, 8, comma 0, 6, comma 6. All these points are put in the objective function and you obtain 36 and 36. The question was to find maximum value, yes, but you're getting two answers. At 8, comma 0, that was this point over here, 8 comma 2, this is the point, and 6 comma 6. So what we understand is there are two solution regions for this particular point. That means this entire line is the solution region. So when we write the answer, we tell in this particular line, right? Because see, one line was y is equal to 6, one was x is equal to 8, not those. Which is the common line? Y plus 2x equals 18. So what we tell is this is this entire line, every point on this line, within which two constraints. Where is it? From here to here, all the points are the solution region, because if you keep on finding it, you'll just get the same answer at all those points. So please make sure it's not all the line, it is from here to here. So what is the domain? From x is equal to 6 to x is equal to 8, this is the solution region. That's the answer, okay, from year to year. That's it. That's how we solve it. The same concept over here, you can try it by yourselves. Just try to do a rough sketch, okay, because over here these are two straight lines. These are all straight lines. It's simple, but there's one slanting line. So just draw all the points, all the lines first, and then mark the points, and then you can easily find the vertex points, and then put the vertex points in the objective function, find the maximum or minimum, whatever is required. So over here, max and minimum, the answers are over here. Please do solve it by yourselves and then check the answers. The example 4 is about real world problems about unbounded feasible region. So let's go through them now. A veterinary recommends that a new kitten eats a diet that includes at least 1.54 ounces of protein and 0.56 ounce of fat each day. Use the table to determine how much of each cat food should be used in order to satisfy the dietary requirements at the minimum cost. Now, the cat food brand is given Good Star and Sirius. Proteins are over here, fat is over here, and cost. Now, whenever we see this cost, that is the objective function. So let's consider Good Start as x, this as y. Now, what is this objective function? It will be 0.36x plus 0.22y. And now, what about the other things? Here, these are the proteins, right? From x and y, from x and y. Now, they're clearly mentioned the protein. Let's write it as an equation, 84x plus 0.56y must be at least, it can be greater than or equal to 1.54. That's mentioned here. And what about the next one? Same thing, 0.21x plus 0.49y must be at least, right? Again, at least, both are at least. So greater than or equal to 0.56. And then the objective function is f of x comma y, that it will be equal to 0.36x plus 0.22y. So these are the objective functions, and then you can just graph them up. Here we have the constraints, the first two equations, and then the objective function, which was over here. Now here also again, it should be positive, right? Because you can't have negative, so x and y must be greater than or equal to 0. So that's it. Now when you graph it up, you will get this. This is the graphs. Now here it must be greater. Both the equations are greater. Look over here. Both our equations are greater. So what happens is you have unbounded region. Why? Because both are going up. And therefore, which is the minimum, right? What we want is minimum cost. So we are looking for the minimum cost when you apply all the three vertex points in this unbounded solution region. You're going to get minimum cost at x is 0 and y is 2.75. Since we have got the minimum cost for this particular interval, that is 0, 2.75, that means you do not need to buy any good start food brand. Only if you buy Sirius of 2.75 units, that's enough, and that will be the cheapest option. Similarly, there's another real world problem. Please do try this by yourselves. You can pause the video now, try it by yourselves, and then continue watching. Here, according to the manager of a pizza shop, the productivity in worker hours of a workers is related to their positions. One worker hour is the amount of work done by an average employee in 1 hour. For the next 8 hour shift, she will need two shift leaders. Okay, this is mentioned already. She requires two shift leaders, at least two associates, and at least 10 workers, total 10 total workers. She will also need to schedule at least 120 worker hours to meet the customer demands during that shift. Okay, everything is given. We need to write the objective function and the constraints. Now, here they need workers, at least 10 workers. Okay, and they must satisfy these conditions. So, now let me just explain you about worker hours and work hours. So it's an 8 hour work shift. So now imagine they start at 12 noon, it'll be over at 8. So there are 8 hours, 8 p.m., 12 p.m. What does a worker hour mean is if he is an untrained employee, just an average employee, whatever work he does in 1 hour is that's it. One worker hour and 1 hour of work, it's the same work. Whereas if you hire but skilled employees, say for example associate, if associate is hired, whatever work an employee does in 1 hour, he can do more easily because in 1 hour, this associate can do 1.5 times the work of an employee. So it's more work being done over here. So the wage over here is also expensive, a little bit expensive for this particular associate. Whereas the shift leader, he does twice the work of an employee in just 1 hour because depending on the positions, right? And over here, the wage is also more. So now let's try to write down the constraints. What I'll do is I'll first write the objective function f of x comma y. Now here, please keep in mind it's not x, y, z. It's only x for associate, y for employee. That's it. This is already told. It's already set. So you need to just keep on adding this up in the sense. Now, what is the wage for an associate? It is 7.5x. But now, this will be a bit wrong over here. Why? Because we know it's an 8 hour shift. Don't write 7.5. It should be 7.5 times 8. Okay? Wait, let me do that in a while. But let me write 7.5x plus, what is this? 6.5y plus, what is the wage you will have to pay for shift leader? It is 9, but how many shift leaders are there? There are 2 shift leaders, so you have to add 18. This is the objective function. All the cost will be added over here. And multiply, this is for 1 hour, right? One working hour, like 1 hour. This is multiplied by 8 because we need for an entire shift, you need to multiply it by 8. So x comma y. Now we'll multiply everything by 8. The reason being each shift is 8 hours. So it's 60, that's 60 times x. And over here we have 6.5 times 8, that is 52. And we have 18 times 8, 180 minus 36, that would be 144. So we can easily do it now. 60x plus 52y plus 144 when you multiply this a throughout. Again, I'll just repeat, this is for 1 hour. The wage is per hour. But then when you multiply this over here throughout, you will see this is the wage. So for one shift, basically an employee gets 60 dirhams, whereas an associate working would get 52 dirhams. And one shift leader would get multiplied by 8 would be 72. But since there are 2 shift leaders, we get 144 in total. This is the objective function. Now, what are the constraints? Constraints, let's write the constraints out. Here, for the first, she will need 2 shift leaders. That is already told that we can't, it's not a constraint, that is already decided. So basically, there are two shift leaders no matter what. But what we have is at least two associates are required no matter what. So now we will write that X associates must be greater than or equal to 2. It can be more than 2, but there must be at least two associates. And if we add X plus Y, this must be greater than, at least greater than or equal to 10. Okay. Now, at least how many working hours? That is 120 worker hours. So now for worker hours, we have to consider this thing. So it is basically 1.5x plus 1y, because 1y, plus 2 into 2, right? This is 1, 2, another 2 will be there. So it's plus 4. Okay. Must be, now one more thing. This needs to be all multiplied by 8. I won't write the entire equation. Let me multiply this first by 8. Why do I multiply this by 8? Because for the entire shift, a shift is 8 hours, right? This is for 1 hour, 1.5. So let me just multiply this. 1.5 times 8 plus 4 is 12x plus 8y plus 8 fours are 32. Now this must be greater than or equal to how much? 120 work hours. So this is the constraint. This is the important constraint. Now that's it. These are all the constraints which we have, and then we can directly solve the problem. So you can see over here, let X be the associates. The first one was associates. The next one was the number of employees. The objective function, now we can see here it is 7.5x plus 6.5y plus 18. This is for 1 hour, but the shift is of 8 hours. So multiply 8 throughout, you're going to get 60x plus 52y plus 144. That's what we got. Then the first constraint was X must be greater than or equal to 2. X, okay, now this is one important thing. I will not edit this from the video. I'll just keep it over here so that everyone won't do the mistake that I did over here. So what happened is X plus Y, I told the workers must be greater than or equal to 10. But I forgot to include the two shift leaders. That they are already there. So X plus Y plus two shift leaders are already there, right? That must be greater than or equal to 10. And then lastly, we had over here 8 times, what is the thing? Productivity, work hours. Worker hours must be greater than or equal to 120, right? So 1.5x times 8 is 12x. Yes, 12x plus 8y plus 32y, because there were two shift leaders already. So we have to add their work hours as well. 4 into 8 will be 32 work hours. That will be greater than or equal to 120. So these are all the constraints we get. Now, please don't forget what I forgot. This is very important, even adding the shift leader. So because they are already mentioned, there'll be two shift leaders no matter what. We have to just consider their values as well. So then you can just graph it up. We have done the graphing before, and then find the vertices, put it in the over here, this objective function, and then you will understand which gives you what values. So now you can see if the shop has 6 associates and 2 employees, that will be the minimum cost. Because if you have 6 associates, 2 employees, and then there are 2 shift leaders, you will be spending minimum cost of 608 dirhams for that particular shift by paying the wages, and then you can earn more profit. So that's the end of this particular lesson. All the problems are similar, the concept is similar, it's just that here and there the problems get deviated, whether it's a unbounded region or you will have many regions in one line, many solutions in one line. That's the only thing which you need to look for, and make sure you go through the main 3 important steps. First step would be writing the constraints and writing them in the slope intercept form and standard form. Second one would be graphing those and finding the vertex points. Last one be from the vertex points, put it in the objective function and solve for the maximum or minimum value. So before we leave, a quick reminder to all of you, please do like my videos and share it with your friends. And if you're not yet subscribed to my channel, please do subscribe. I'll see you all in the next video. Until then, wish you all happy learning.